Would you let me know if you can't see the top of my head there, because that would look a bit foolish. Does that look all right in there that you can see?
The top of the head is not in it.
Is it now?
Yes. Yep.
Okay, now. Okay, now here we have the solar system. Starting off with the planets. There are 8 planets, with Mercury, the innermost one, and Neptune, the outermost planet. Now, a planet, by definition, is an object that goes around a star, whether the star is the sun or not, goes around a star. It is more than 800 kilometres in diameter, and it has cleared out its own orbit, cleared out the various bits of debris, rocks and meteorites and bits and pieces from its own orbit. Now, the 8 planets have obviously done this. I mean, for instance, the Earth, as it moves through space, it doesn't tend to run into a lot of large rocks and other planets and things like that. The area is clear, or relatively so. The reason for the 800 kilometres is that once an object gets to 800 kilometres, it's got enough gravitational force to compress it and turn it into a sphere. So anything that's 800 kilometres or greater will actually be spherical in shape. If it's less than 800 kilometres, it can be an odd shape and it's not counted as a planet. Now, any object that is more than 800 kilometres that goes around a star but has not cleared its own orbital path, in other words, there's still a lot of debris there, is called a dwarf planet. And we have a couple in their series, Eris, Pluto. Pluto is being classified as a dwarf planet. Pluto and Charon, that's Pluto there. Charon, its moon, is there. It also has 2 other smaller moons. Now, there are a couple of other ones that have been added to the list quite recently. So we have about 6 or 8 dwarf planets. So we've got the 8 planets, a number of dwarf planets, and we have the asteroids. Now, the asteroids are in a belt between the orbits of Mars and Jupiter. There's Mars there. Here's one here, Eros. A spacecraft actually landed on that at one stage. It was a sort of a last-minute decision to do it, but they landed on there. And here's Ida, another one, and it has a little moon called Bactyl. So some of these little satellites, they may only be anything from a couple of kilometres to hundreds of kilometres across. Some of them have moons. Some of them have more than one moon. Now, if we go out further beyond the asteroid belt, right out to Neptune. Now, here's Neptune there. There's the Sun in there. There's the various planets there. Neptune here. Now, if we go out beyond Neptune, what we find is there's this huge belt of objects called Kuiper belt objects. This belt here is made up of objects which are mainly dirty snowballs, really. They are made up of rock and ice and material like that. And they circle around there, usually in very elliptical orbits. Some of them can go way out here and come in. Some can even go in a bit further than Neptune. Now, these objects here form a disk around the Sun beyond the orbit of Neptune. And some of these objects, well, Pluto is one. Pluto is actually a Kuiper belt object. You can see it's got a very sort of squashed orbit. Most of the planets have got more or less circular orbits. Not completely circular, but more or less circular. Kuiper belt objects tend to have elliptical orbits. In other words, they're orbits that are squashed like an egg, and they're pushed out like that. So we have the Sun in the centre, we have the planets and the asteroids and so on there, and beyond that we have the Kuiper belt, which is made up of these things. Now, it's really interesting because these things are all going around here, and once in a while something might happen. They might collide, or you may have a passing star. It doesn't happen very often, but it has happened. A passing star will disrupt the orbits or something, and some of them will tend to fall inwards in towards the Sun. They'll be disrupted from their normal orbit and they'll fall in towards the Sun. As they get closer to the Sun, as they say, cross the orbit of Mars, get closer to the Sun and they begin to warm up. And as they warm up, the ice and gunk and various compounds and so on there tends to evaporate. And that gets caught up in what is called the solar wind, which is a whole lot of gas that's moving outwards from the Sun. And as the stuff bubbles off from the surface, gets caught by the solar wind and swept backwards like that, and forms a tail. And this forms the comets. So, you see, the thing about comets is that every time they come near the Sun, they give off a lot of material. And so each time they do an orbit, they get smaller and smaller and smaller and smaller. And really, you shouldn't expect to see a comet more than about 10,000, 15,000 years old. which means new comets have to be coming from somewhere, and this is where they're coming from. So every now and then you get a new comet coming out of the Kuiper belt and moving in near the Sun. So that's our source of comets. The solar system really is a very busy place, and we've only looked at the various material objects. There's also the magnetic fields and particles and one thing and another going hither and yon. Now we mentioned earlier about comets. How as they moving closer to the Sun, the material on them evaporates, bubbles off and forms a tail moving behind them. Now these comets here, this is comet C2001Q4, you no doubt remember it, such a catchy name, how could you forget? But here it is here, in the centre, right in the very centre there, you've got an object which looks a bit like an asteroid, but is not, and it's maybe 10, 20, 30 kilometres across, something like that. And it's outgassing, it's giving off a lot of gas and material as the comet warms up. The material then feeds into the tail here. Now, that's right in the centre, that's the very object itself, that's the comet itself, and you can't actually see it, they're quite small. Around here is what they call the coma. That's the sort of the atmosphere of the comet, if you like. That's all the gases and everything that are hanging on around the central part here. The central part's called the nucleus, and you've got the coma there, and that's the tail. This just gives you some idea of the orbit of the comet. You can see here, here's the Sun there, there's the orbit of a couple of planets, and here's the orbit of a typical comet coming in through there. Now what's happening here, it's very hard to show it on a flat thing, but there's this disk here, and the comet's coming in like that, coming in at an angle. So you've got the planets all arrayed in a disk arrangement there, and the comets will often come in from above that disk or come up from below it, and you can see that's what's happening there. A number of years ago, again I don't know if you recall, there was this comet headed for Jupiter, Shoemaker-Levy, and as it moved into, it turns out that Jupiter actually sucks in a lot of comets. It's rather beautiful actually. It's a sort of a vacuum cleaner, and it actually gets these comets, it sucks comets in so they don't hit us, which is very convenient. This comet, as it got near Jupiter, began to break up, and it broke up into about 20 different pieces, and they're all barreling towards Jupiter, and unfortunately it wasn't possible to, because of the timing and one thing and another, it wasn't possible to see the actual impact. But nonetheless, it was observed, and the bits hit one after another, and they hit just around the corner there, and then the planet rotated, and these came into sight. You had these great big bruises on the planet. Now Jupiter, we'll look at that in detail later, but Jupiter is really a big ball of gas. It doesn't have a solid, this isn't the solid surface here, this is just cloud tops. And these things went screaming into the atmosphere. They got down about 50, 60 kilometres and then exploded. And one of them created a fireball 2,000 kilometres across. That was just one of them. And it dredged material up from underneath the clouds, this browny sort of stuff, and just sprayed it all over the surface. Now that's larger than the size of the Earth. But that was a very exciting day, or a couple of days it took for the whole thing to happen. But it was actually seen, actually a couple of weeks ago someone observed another comet hitting Jupiter. I think they've seen 3 or 4 hit Jupiter since then. So, in the space of a decade, maybe you have 2 or 3, 4 comets hitting Jupiter, which is a lot more than they expected. So it's jolly handy that it does, because if it didn't, well, they might go somewhere where they'd be a real nuisance. Now, there's meteors. These little shooting stars you see happening in the sky, little bits of stuff. Basically, they're usually just little bits of rock, maybe the size of a grain of sand, maybe a small pebble, something like that. There's stuff floating out there, and it gets too close to the Earth, the gravity pulls it in, hits the upper atmosphere, high enough speed that it will actually heat up from the friction, and you get this sort of effect here. Sometimes you'll find that you get large showers of these meteors, large numbers of them will come in, maybe you might get one a minute or something for a time, and these are called meteor showers, and if you're really patient and you go and they're quite regular. They know when they're going to happen and what part of the sky they're going to be in. Now, your meteors are as much a part of the solar system as comets and asteroids and so on. And there are a number of different types of meteors. We have our stony meteorite, which is made largely of stone. Thing about astronomy, of course, it's not really hard to learn, just a couple of things, and you sound like a genius. These things, as far as we know, are leftover bits and pieces from the formation of the solar system. They may be, some of them would actually be bits of asteroids that collided. You know, two asteroids that collide are smashed together and throw off a lot of debris and rubble, and some of that eventually finds its way here. Some of it actually comes from Mars or the Moon. Now, the Martian meteorites are really sort of fascinating, because they used to find these meteors of a certain composition and they didn't know where they were from. Anyway, when they sent spacecraft to Mars, they were able to sample the atmosphere. And then they found that these particular meteors had little gas bubbles in them. So they were able to suck out these little minute bits of gas, and they were an exact match for the atmosphere of Mars. So now that can't be coincidence. It's got to mean that rock somehow came from Mars. And what they believe has happened, and it makes a lot of sense, is that a meteor or something hit the Martian surface, threw material up, and some little bits of that were thrown up fast enough to actually escape from Mars and drift through the solar system and eventually come here. It may take millions of years for that to happen, but we know that the same things happen with the Moon. There are meteorites that have come from the Moon, we know that, and we know also that some of the Earth stuff has gone to the Moon and gone to Mars. So there's a bit of a two-way transaction going on here. We have here iron meteorites. Now, iron meteorites are made of iron. Where you most commonly find iron is in the core of things like planets and asteroids and stuff like that. You don't normally find lumps of iron floating around in space. So somehow, probably some giant collision between two large asteroids or something like that broke it up and allowed some of the iron to get out. Then, of course, we have the ones with a two-way bet. We have stony iron meteorite, which are made up, as you can see, of stone and iron. Your carbonaceous chondrite, which is like a stony meteorite, and it's got a lot of carbon in it. Now that carbon is a very common element in the universe. It also happens to be what we're made of, and what all living things are made of. But this doesn't mean that there was life from wherever this came from, because, as I say, carbon's a very common element. But this has come from some source where there's been a fair bit of carbon mixed in with things. Here's the Mars meteorite, the one I was talking about. Now, there are quite a number of those. This is just one that's got a name there and a number. And as I said earlier, they were able to find out where it came from by comparing the composition of the gas bubbles inside. Now, the minute little gas bubbles. Moon meteorites, again, they know these are from the Moon because they've been to the Moon and they've got rocks from there. They know what the Moon is made of. They know its composition. And this one exactly matches that. So you can actually tell where these things all came from. So we've had a look basically at our planets, our dwarf planets, asteroids, comets, meteors, and there's also a general haze of dust out there. The solar system has a fair bit of dust in there, some of it left over from the original formation, other bits of it just sort of formed from collisions and so on.